Suppose you find yourself in a bit of a situation where you have two things in need of fastening, and you're right out of the right size nut and bolt, and it's the weekend and you just can't afford to wait until Monday, so you ask yourself the very simple question, I have a 3D printer, why can't I just 3D print a nut and a bolt? Now, obviously you can get a giant oversized bolt out of your printer, no problem, but if you want to get a small, say M3, M4, or M5 bolt that you can actually use in real life applications, well, that's what we're going to find out. Now, if you're using Fusion 360, getting a 3D CAD model of a bolt is as simple as going to Insert, select the McMaster car component, select Bolt. Now, for your average 3D printer, you're better off not picking either a hex or even a Phillips head screw, because with a bolt of that size, the corners will be generally rounded and the plastic brittle enough that you either won't be able to turn it or you'll break it when turning it. So make sure to select a flat hex head screw right here. Now, select the right options. Make sure you're in metric. Select M5 for starters. So you don't want to select the one with the wee numbers there because that might mess up your slicer. You grab the CAD model right from the product details page. Make sure to select step, not SolidWorks, because even though it works on some people's computers, it didn't work on mine. And there you have it, a beautiful little bolt ready for slicing and printing. So here's the little bolt we just printed. As you can see, the thread is present, and I mean not that bad for a 3D printed bolt. Here's the nut, also printed. Now let's see if it will go in. Yep, it slides in super smoothly, at least halfway through, because once you reach the end it kind of gets stuck. I suppose it's because of the tolerances and the general blobbiness of 3D printing. But with a little force, I mean, it goes in all the way, no problem. So, there you have it. Fully functional M5 bolt and nut that you can use for any application where it doesn't really need to be structurally strong. So, there you have it. Imagine all the possibilities with this. So next up, we have the M4 bolt. Will that one work? Because then you're getting a wee bit small there. So here's our M4 bolt. It's a bit roughed up. I don't know if that's because of the printer, but we'll still try and make it go through the nut. I'm actually more worried about the threading inside the nut than the bolt. Because yeah, it goes in a bit, but then it starts squeaking. Yeah, it gets stuck there. Well, since the nut didn't work, let's try and see if the bolt will go inside a metal thread. We got this motor here, and we'll try and slide it in. Yeah. Yeah, we got it. Oh. Now, it kind of gets stuck after a few turns. But, let's see if we can brute force it in with our pair of pliers. I mean, the plastic's probably soft enough that it'll just get threaded by the metal bits itself. So let's go. Ooh. Yeah, that just snapped right off with a little force. So yeah, that tends to happen quite often when you're dealing with tiny, thin parts. On the bright side, the M5 bolt had no issues. I didn't even have to play with the dimensions of either the nut or the bolt. It just went straight in with the dimensions from the McMaster catalog. So that's good. I suppose if you really want to insist on using a 3D printed bolt, try and make sure your holes are big enough for M5 or above, because otherwise you're probably better off just using duct tape at that point. So, until next time.